This is lesson 12.4. We are going to be factoring equations that are in this form, so a trinomial. And they may be an equation or they may be an expression, but we're going to be factoring those out. So we've talked about factoring, but we've really only looked at things that could all be factored out at once. So like if every single term had an x, or every single term had a factor of 2 or something like that. So we're going to look at situations where that's not true, but it's a special form of factoring, looking at the products and then what the sum of those products are. So if you take a look at these first two problems here, kind of walks you through just how to expand these, which we already know how to do. And we're going to take a look at the results and see if we can't work backwards. So if I gave you this and said multiply, you would do x times x and get x squared, x times 3 and get 3x, 4 times x and get 4x, and 4 times 3 and get 12. And you'd combine like terms and end up here. Same thing down here, right? So we know how to do that. Now, how do we get from here back to where we started? Okay, that's what it's going to look like. So I'm going to give you an expression like this, x squared plus 7x plus 2, and ask you to factor it. And so if you look at these three terms, there's not one thing in common. They don't all have an x, and this only has a 1, so I'm not factoring out a number. But I need to be able to get from all of this back to here. Okay, and there's some big advantages when we're working with equations to getting it back into this form. And we'll see on the back side of this, we can actually solve the equations, if they're in the right form, by putting it into this factored form. So what I want to do is look at the different pieces of this equation, starting with the 12. Okay, if you look back to the original, 4 times 3 equals 12. If you look back to the original, negative 6 times 8 gives you the negative 48. So this 12 is the product of 4 and 3. And this is the product means multiplication, of negative 6 and 8. So that helps us a little bit, right? But when I look at 12, 4 and 3 aren't the only things that multiply. So how do I know that it's a 4 and a 3? Because how come it's not a 6 and a 2 or a 12 and a 1? Right? There's other things that multiply to make 12. And if I just said x plus 6 and x plus 2, that would be incorrect. That's different. Okay, so what we also have to do is look at this term. We're relating it back to the original. Where does a 7 come from when in relation to a 4 and a 3? Well, 4 plus 3 is 7. So 7 is the sum, when we add them, of 4 and 3. So going back to my 6 and 2, right? 6 times 2 is 12, but 6 plus 2 is not 7. 12 times 1 is 12, but 12 plus 1 isn't 7. So the only products of 12 that also have a sum of 7 is 4 and 3. So on this one, the product of negative 48, we looked back here and kind of cheated and said it's negative 6 and 8. But what if we didn't start with that? Well, negative 48 has a lot of different products, things that multiply into it, like 24 and 2. Okay, negative 6 and 8. Or what about positive 6 and negative 8, right? We can flip-flop all of that. So when we do work backwards, which is what we're going to be practicing here in a second, we always have to start looking at this and think about what is the sum. And so if I have 8 and negative 6, add them together, the sum is 2. So this term right here is the sum of negative 6 and 8. So hopefully that seems easy enough just looking at it. Like, okay, these two numbers multiply to make this and add up to make this. They multiply to this and they add up to this. But what happens when I don't actually get to see it all? How do we figure that out? So that's what we're studying today. You're going to be given an expression as a trinomial, and we're going to factor it. Now, let's say it right up front, not every single trinomial in the world can be factored into this form. There are ones that are called prime, just like we have prime numbers that can't be factored. Okay, you can have a prime expression that can't be factored either. So not every single one of these trinomials could possibly be factored, but we're going to look at specific ones that can be. Okay, so what we want to do is we want to start kind of making a list of factors of 18, because it always goes back to that. If we're going to go ahead and write this as an answer. So it's going to be x, and I'm not going to put plus yet because I don't know. Could be a minus. But x plus or minus something times x plus or minus something, and I have to end up back here. So what I know is these two numbers, when I multiply them, have to make 18. So I want to think about what are my options. It could be a 1 and an 18. It could be a 9 and a 2. It also could be a 6 and a 3. All of these are factors of 18. They multiply together and make 18. But they don't all have a sum of 11. So this one's already filled in. The sum of 1 and 18 is 19. The sum of 9 and 2 is 11, so that's going to be our magic number right there. And the sum of 6 and 3 is 9. So these are going to be my answers, positive 9 and positive 2, and it doesn't matter which way you put them. The 2 can go here, the 9 can go here. And I know they're going to work because 9 times 2 is 18, and 9 plus 2 is 11. Now you should always double check yourself. Go ahead and expand this like you know how to do. X times x is x squared. X times the 2 is 2x. 9 times the x is 9x, and 9 times the 2 is 18. These combine together to make this. We're good, and this is the factored form. So these are equivalent to each other, but they're just in different forms. All right, so hopefully you can see as we expand this, how come this works? Because this 2 and the 9, they're both going to be multiplied by x and then get added together. So that's why they have to add up to this. And the very last part of this is when they get multiplied together. So we're kind of just breaking apart this equation and then working backwards to figure it out. So here's a little trickier one. So we want to factor this one out. You're always going to start with this term out here. What are the products of this? Or what are the factors of this? What two numbers have a product of negative 30? So I've kind of started a list here for you. Negative 1 times 30 is negative 30, but if I add those together, I get 29. And you got to think about the negatives here. So negative 2, what do I multiply negative 2 by to get negative 30? That'd be 15. If I add those together, that's 13. And I'm trying to get a negative 1 is what I'm trying to get when I add them. So to multiply to get negative 30, I could do negative 3 times 5. Put those together, that's positive 2. I could do negative 5 times 6, positive 6, to get negative 30. That's going to be a positive 1. And just a little hint here, once you get here, if you can just flip-flop your negative, so I had negative 5 and positive 6, negative 6 times positive 5, same two numbers, but now the 6 is negative instead of the 5. They're still going to multiply to negative 30 as long as one of them is negative, not both of them. But when you add them together, now there's more negatives than positives. So this is going to have a sum of negative 1. This is going to be our answer right here. But let's finish this out. Some other numbers. Let's say this didn't work and you had to keep going. What else multiplies to negative 30? That could be negative 10 and 3. That would be the opposite. Oh, I realize I put 5 here. Some of you were probably wondering what I did right there. Negative 3 times 5 is not going to be negative 30, right? It's negative 3 times 10. So that's not a 2. That would be a 7. So hopefully you caught that. You were paying attention. All right, so these are the opposites of each other. If you notice, negative 3 times 10 is negative 30. Negative 10 times 3, also negative 30. We've just switched where the negative is. Add these together, it'll be the opposite of this, more negatives, so negative 7. So there's a couple more. You can do the opposites of these. Since it's a negative, you can just switch where it is. So it would be positive 2 and negative 15, opposite of this. So those multiply to negative 30, and when you add them together, it's negative 13. And then the opposite of this would be positive 1 and negative 30, but those are going to give you negative 29. So this is what I wanted. Product of, when you multiply these together, negative 30, and when you add them together, negative 6 plus 5, you're going to get negative 1. And so that should be my answer. Let's double check it. When you have a negative, you're going to write it as a minus. So x minus 6, x plus 5. Let's expand it. So I'm going to get x squared. I'm going to get positive 5x. I'm going to get negative 6x. And I'm going to get negative 30. These combine to make a negative x. And a real quick check, I've gotten back to where I started. And so this is the correct factored form. All right, let's try one now without the nice little table set up for us. So looking at this, where do I start? As soon as I give you one of these on the homework, where do I start? What do I do? So you're going to look at the 16 and you're going to start thinking of factors, things that multiply into 16. And you can list them out for now. Eventually, you're going to be able to just do this in your head. So what things multiply to 16? And then while you're thinking about it, you can just start in your head saying, do they add up to -8? Because if they don't, then they're useless. So well, first of all, if they're going to add up to a negative, I don't need to talk about factors that are all positive, right? Like 16 and 1, that's going to add up to a positive. Even 8 and 2 is going to add up to a positive. 4 times 4, they're going to add up to +8. So those don't even matter. So how do I multiply to create a positive, but when I add them together, I have to get -8. The only way that's going to happen is if I have two negatives. So -16 and -1. When I multiply two negatives, I still get +16. Put those together, that's -17. All right, -8 and -2 multiply to +16. Together, that's -10 when you add them. No good. And so it's -4 times -4. That gets you +16. And when you add them, you get -8. So those are the factors that also have a sum of -8. And so they're both negatives. So it's x minus 4 times x minus 4. If I believe that's true, I can rewrite this in even better form. This is the same binomial times itself, so I can rewrite this as x minus 4 squared. This would be the best answer. As always, you can double check yourself real quick. You're going to get x squared, -4x, another -4x, and +16. These combine together to make -8x. And we're back where we started. And so this is our good final answer. Okay, let's take it a step further to the back. So consider this polynomial. Let's factor it first. So before we worry about where we're going, let's just go ahead and factor this. So we're looking at 24. We need things that multiply to 24, -24, and add up to 5. So let's think of some numbers. So first of all, if they're going to multiply to a negative, one of them's negative. So let's say like 12 and 2. Well, in my head, 12 and 2 are never going to make a 5. So I'm just going to throw that out. I'm not even going to write it down. Now, if you like writing them all out, that's fine. What other numbers multiply to 24? Well, 6 and 4. 6 times 4 is 24, and I could mess with the negatives. But 6 and 4, whether I add them and subtract them, they're never going to equal 5. And so hopefully you can see it's going to be an 8 and a 3. Now, two positives wouldn't make a negative, so one of them's got to be negative. If I do that and I add them together, I'm going to get a -5. So I actually need a +8 and I need a -3. When I add those, the sum there is going to be +5. So this is my answer right here. +8, -3. Multiply them together, I get -24. Add them together, I get +5. So my factored form here is going to be x plus 8 and x minus 5. All right, so step B now. I want you to use the quadratic formula to solve this. So notice that this side here is this polynomial that we factored. Now, using the quadratic formula, your A, B, or C, if this is all equal to 0, remember, you can't use quadratic formula unless it's all equal to 0. Go ahead and solve it. So A is 1, and B is 5, and C is -24. So again, quadratic formula, -b plus or minus b squared minus 4ac over 2a. So -b is -5 plus or minus 5 squared minus 4 times 1 times -24. All of that over 2 times 1. All right, if I run everything in here in the calculator, 5 squared minus 4 times 1 times -24. Go ahead and run that through. You're going to get 121. So I still have -5 plus or minus square root of 121. 2 times 1 is 2. Square root of 121 is a nice number, so this is -5 plus or minus. That is 11. And of course, we split that now into two pieces. negative 5 plus 11 over 2, negative 5, I wrote 15, negative 5 minus 11 over 2. So negative 5 plus 11 is positive 6 over 2, which is 3. And then this is negative 16 over 2, which is negative 8. So my answers here, x equals 3 and negative 8. And now I want you to look up here and make a connection, and I've noticed I've made a mistake. So I went from this to this. Well, what's wrong? It's supposed to be 8 and negative 3, and I wrote negative 5. Obviously, I was pulling it from here while I was talking. So I apologize if there's some confusion there and I left you behind. This should be a minus 3. So here's your 8 and your minus 3. And this is what I want you to do for part C, is to make the connection now between these two. Explain the connection between your answers. And so you would say, now notice this is a negative 3 and a positive 8, and I got the opposite. So the answers are opposites. And now here's what it actually is. Remember, if this was an equation equal to 0, this would be multiplication. So the only way you're going to multiply two things together and get 0 is if one of them is 0. And so for this to be true, we need values of x that make this 0. So what value would I plug in for x here to create a 0? Well, it'd be negative 8, because negative 8 plus 8 is 0. And then it doesn't matter what I get over here. It's going to be 0 times something is 0. And then what about this one? What can I plug in for x so that this whole thing becomes 0? Well, that would be 3. 3 minus 3 is 0. And it doesn't matter what's over here. 0 times anything is 0. So using this factored form, you can actually get the answers. Okay, and so when we were doing all this quadratic formula, if you remember, I was talking about how, look, this is the long way, and it works every single time, but there are faster ways that at first seem a little trickier to understand, but once you've got it and you factor it, you've got your answers, and you don't have to go through this whole big, long process. Okay, now there are polynomials that will not factor. We talked about that quadratic formula will solve for. Okay, so this is not the be-all, end-all. There's going to be situations where factoring doesn't work, and you have to fall back on quadratic formula. Okay, but there's going to be plenty of times that you could factor it, and you should factor it because it's way faster. Okay, so the answers here are the values of x that make, and these are the binomials that make the binomials equal 0. So I can solve these two different ways now. You've got a new skill. You can solve these equations two different ways. And so that's what we're going to do now on the bottom. We're going to solve this equation using factoring and with the quadratic formula. So let's try it with factoring first, and then we'll use the quadratic formula to double check our work. All right, so first of all, 6. Products of 6. Notice I don't have any negatives in this problem, so I'm just dealing with positives. Well, it could be 6 and 1, could be 3 and 2. Out of those, which ones add up to 5? And you might say, well, either one, right? 6 and 1 could, if you were minusing, or 3 and 2. But to create a positive 6, the only way that could happen is if they were both negative or both positive. Okay, so I can't make just the one negative to get myself to the 5. 6 plus negative 1 would be 5. But if I multiplied 6 times negative 1, I'd get negative 6. So that doesn't work. So I know to get this 6, I'm either multiplying two negatives or two positives. And if they're adding up to a positive, they both can't be negative. So the 3 and the 2 is going to be the correct ones. 3 times 2 is 6. 3 plus 2 is 5. And so in factored form here, it's x plus 3, x plus 2, equals 0. And so the answers aren't 3 and 2. The answers are what I would plug in for x to create an equation that's true. So either one of these binomials would have to equal 0 so that when you multiply them together, you actually get 0. So what number would I plug in here to make this whole thing 0? Well, it's going to be the opposite. because it's something plus 3. I need it to equal 0. So x equals -3. If I plug it in, I get 0 or -2. So it's always going to be the opposite of these. So you plug it in, -2 plus 2 would be 0, and it makes this equation true regardless of what's over here. So using factoring, we've said that the answer to this is -3 and -2. So let's test it out with the quadratic formula. We know a is 1, and b is 5, and c is 6. So it's -b, so -5, plus or minus b squared, 5 squared, minus 4 times a times c over 2 times a. Okay, you run the inside here. This is 25. This is 24. 4 times 1 times 6. So it ends up 25 minus 24. So you end up with -5 plus or minus square root of 1 over 2. Square root of 1 is 1. So it's -5 plus or minus 1 over 2. So -5 plus 1 over 2. -5 minus 1 over 2. Okay, that's -4 divided by 2. It's -2. And then this is -6 over 2, which is -3. So x equals -3 and -2. We've backed up our factoring skill and shown that it actually works. Now, which one would you rather do? This one, all day, every day. This takes a while, and again, it works every single time, and there's going to be times you're going to experience this in the future where you can't factor something out. That doesn't mean it doesn't have an answer. You can go ahead and you can use your quadratic formula, but when it factors, this way is much, much nicer. So you're going to like this a lot compared to going through the whole quadratic formula.